This video is going to introduce another one of those existence theorems that are common on the AP test. This video will address the use of mean value theorem for derivatives. There is another mean value theorem for integrals, but this mean value theorem only involves derivatives, commonly abbreviated MVT. When using mean value theorem, the format you follow on free response items on the AP exam is to establish all the preconditions for the theorem, the hypotheses for the theorem, and then triple dot by blank theorem, blank is guaranteed to exist. This is an existence theorem. Step 1 for mean value theorem, usage. Establish continuity. F is continuous on the closed interval a comma b. Step 2, establish differentiability. F is differentiable. Smooth on a comma b. That's it. Those are the only two preconditions for mean value theorem. You can make your triple dot statement. Therefore, triple dot by MVT there is at least one magical value C. Oh, and by the way, C is going to be between A and B, such that F prime at this magical place, this magical value C, is exactly equal to F of B minus F of A over B minus A. Terrible looking A. Period. Now, some useful annotation. This is the form of mean value theorem you apply on the AP exam. Now let's annotate this just a tiny bit, not required for the AP test. And let's go through the graphical intuition of mean value theorem, especially because this is a common multiple choice item. On the multiple choice, they're not testing you on your ability to regurgitate the exact format and flawless use of this theorem like it's geometry class proof time. They're wanting you to understand the conceptual meaning of this, and that starts with this annotation. This F of B minus F of A over B minus A has an exact meaning. That is the average rate of change of F on the closed interval a comma b. Think y2 minus y1 over x2 minus x1. This is a difference quotient. This is an average rate of change of F. Whereas this, you can think of this two different ways. You could think of this as the instantaneous, as opposed to average, the instantaneous rate of change of F at x equals c. You could also think of that as the slope of the tangent line to the F curve at x equals c. So what mean value theorem establishes is there's going to be at least one input where the slope of the tangent line to the F curve is the same as the average rate of change of F on that interval. Let's zoom out and let's look at this graphically. Please make sure this is flawlessly in your notes. And the next time I give you, or the first time I give you, an existence theorem FRQ prompt, be prepared to use this setup. Maybe even apply this on your homework a little bit when you can. Okay, intuition. We're going to go from here, A comma F of A, to here, B F of B. And F of X is going to be blue. F of X is blue. Now, F of B minus F of A over B minus A would be the slope of the secant line connecting these 2 points. So this is not F that I'm drawing. This is just a secant line connecting 2 points on the f curve. The slope of this secant line is the average rate of change of f on the closed interval a comma b. Now, what does f actually look like? F could have many forms as long as f is continuous on AB and differentiable on AB, closed interval, open interval. I'm going to draw something pretty boring for the first example. What if I just had an f that looked like this? F is smooth, f is continuous, f is differentiable. And you could see there's probably at least one place where the average rate of change matches the slope of the tangent line to y equals f of x at x equals c. And we can find that a little bit better with our clear ruler here. Let's see how well that shows up on camera. Not bad. That's probably good enough. It looks like there's our magical c value where the slope of this tangent line, see how the slope of that tangent line matches the slope of the secant line. The average rate of change of f on a comma b is equal to f prime of c right there. If this was drawn perfectly, of course, with the red tangent line parallel to the green secant line. And if there is no such location C satisfying this, that means one of these two preconditions must not be met. Now also notice, it says at least one value C. There easily could be more than one. And on recent AP tests, it's often been 3. And you can imagine how F might be drawn where you get 3 such locations. Now, if you've already watched the video or already learned about Rolle's theorem, all Rolle's theorem is mean value theorem when f of b minus f of a is 0. If f of b and f of a are the same, mean value theorem collapses down to Rolle's theorem, but that's for another video. So imagine if we went from here to here, from a comma f of a to b comma f of b. And again, this is the green secant line connecting a comma f of a to b comma f of b. The slope of this green secant line is the average rate of change of f on a comma b. Now, how could I get more than one such c value? Maybe we have a graph that does something like this. This is f in blue. F is continuous, f is differentiable, nice and smooth. And there look to be a number of locations where the average rate of change is equal to the, that's not terrible. Oops, good enough. Looks like about right there. The instantaneous rate of change of f would be about the same as the average rate of change of f on the interval AB. And it looks like we get another such location pretty close to there. It looks like there's another one there. And it's not like they're going to test you on finding these locations exactly. Unfortunately, I'm going to have to compound my errors here. Since I was so far off on this one, we're going to be just as far off over here. Doesn't got to be perfect. This is just for the concept. It appears that I have a first C value right there. That'd be my C1. That'd be my C2. Maybe right there. That'd be my C3. F prime of C1 is not 0. F prime of C1 is the same as F prime of C2 is the same as F prime of C3, which is equal to F of B minus F of A over B minus A. They might give you a curve like this on the AP test and ask you about how many locations would satisfy mean value theorem or something of that nature. So the graphical part, which I hope you recorded in your notes, is very useful for multiple choice items on the AP exam involving mean value theorem. That conceptual knowledge of what the application of mean value theorem looks like graphically versus Your ability to spit out this exact format of theorem usage like it's a geometry proof in 8th grade is very useful for free response theorem items, which you're likely to face on the AP test or maybe your Chapter 3 test in my class.